Great. Okay, well, thank you very much for chairing this second session and for all the talks earlier in the day. I'm Jeff Welker. I'm with the University of the Arctic, and I have a joint appointment between Oulu University and the University of Alaska in Anchorage. And what I'd like to do today is talk to you a bit about networks in general and share with you some of the work that's quite important that's being done today, and then say a few things about the future. And here's just a brief outline. I'm going to say a little bit about history so that we kind of reflect on how we got here today, plethora of networks that we have, say a few things about their importance, and then talk about their combinations of research, teaching, and service. And I really needed to begin this presentation by this new article that just came out on the history of Sodonkula. Finland has clearly been very instrumental in this whole thematic area of developing networks globally. And this article, again, came out of one of the faculty at Oulu, and I just thought it was only fitting that it reminded us of the role of FMI and the group here in Finland in terms of some of the important work. And much of this begins in the late 1800s. And since that time, there have been a whole series of networks and programs that we've all witnessed. Some of us are old enough to have participated in. But one of those that is really exceedingly important was the International Biome Program. And that was preceded by the International Geophysical Year, about the time many of us were born. And this International Biome Program was exceedingly important here in Scandinavia, included both tundra and forest biomes, and that led to several programs that have developed since. For instance, the International Tundra Experiment, again, experimental work instead of just observational work. We've also had another IPY year here previously in 2007, 2008, and then we moved into programs such as ICOS. The IGY, again, very, very important time period for the scientific community. And again, Finland was very instrumental in this and focusing on questions that we still have today about solar activity, glaciology, which today is the Cryosphere. And it was also the beginning of satellites in space, which led to the NASA program. And as you can see, it's a time period when stamps were really valuable. And so this shows you that it's a different era, but some of us can appreciate that even today. And one of the places that was especially important was Svalbard. And Finland itself has a research station on Svalbard that was part of IGY. This is up on a place called Nordisland. It hasn't received a tremendous amount of use, but I see it personally as a place that could be a real new opportunity for Finland in the high Arctic, and a place that there's even a book about it. If you go to the Svalbard and go to Longterm, go to the museum, you can buy a beautiful book on this field station. I bought one for my rector. The other program that really set us off in terms of where we are today was the International Biome Program. And here in Finland, KEVO was very instrumental and participated in this. At the time in the U.S., our long-term site was at Barrow, and you can see that throughout the globe there were many, many stations that were involved, and some of them still active. And so these represent some of the records that we're using today to really understand the past so we can think more about the future. And it really, really drove home this idea of coordinated large-scale ecological and environmental studies, which we continue today. The IBP program was kind of descriptive ecology. And one of the things that it did, for instance, was it was able to show us and help us understand that these biomes could often be displayed in kind of temperature and precipitation regimes. And many of these you're familiar with from your early courses in ecology, for instance, or geography. And the framework that they put forward was something that took, again, years to agree upon. Communities from all over the world participated in designing this program. But in today's world, IBP started us on questions of carbon fixation, for instance, and variation in productivity, questions we're still working on today. It talked a lot about food webs, predator-prey relationships, whether it be insects or polar bears and seals. Ecosystem respiration, we know how important that is in terms of understanding the carbon budget, and we've come up with all kinds of ways to measure that, as well as mass and energy fluxes, many of those focused on the water cycle, and microbial ecology really has its roots in this IBP program and continues to be some of the major disciplines today that we see in a lot of our terrestrial and ecology networks. One of the places where long-term research continues in the U.S. is pictured here. This is Toolik Lake, Alaska. It's the site of our long-term ecological research site. Much of the research that was kind of terrestrial-based moved from Barrow about 1970, and Toolik Lake now is home to much of our work on aquatic systems, lake systems, stream systems, as well as landscapes, and has been my home since 1994 in many ways. One of the big issues that we're grappling with today, and now has become carbon neutrality, is this whole issue of how do we know what the carbon budget of landscapes are and what ocean systems are. And one of the things that we've come to learn only about 15 or 20 years ago, that if you're not studying winter carbon fluxes, you're not learning a lot about the way the boreal or the Arctic work. And we started this in the mid-1990s at Toolik Lake, and that has continued to be one of the big gap areas of research, is how are these ecosystems behaving in winter, and what fraction of the carbon emissions occur in winter as opposed to summer. This paper with Sue and others really highlighted this a few years ago. And one of the questions that we often ask ourselves is, what's the value of a network? How do you know that a network is really providing value? And here's a nice example of that, which was recently published, where folks were using the ICOS network during a real extreme drought period here in the Scandinavian Nordic region. And what the network was able to do is to show us, again with the different colored circles and some of the circles below the line and some of them right above the line, was there is tremendous disparity in the sensitivity of these ecosystems to something like an extreme drought condition. And so this again is, if the only place you were working is southern Finland, your perspective on that would be very different if you didn't have sites, for instance, in northern Finland and other parts of Scandinavia. So this really shows us the value of having coordinated sites that are working together. The other program that some of you may be a little bit less familiar with is a program that's really focused on individuals, on people that are involved in the research community, and this is the program called Interact. Terry Callahan, who is a kind of child of IBP in many ways, grandfather to many of us in terms of collaborative research in the Arctic. Terry has been a real leader in helping organize this. And it's a program that is about exchanges. It's about undergraduates from Helsinki coming to the University of Alaska Anchorage. It's about students participating in research in different places. And this has become really infected the next generation with how we do research. And so it's a real cornerstone of a network that we have today that's been tremendously successful and has recently just entered, I think, its second 5 years in terms of being active. One of the big concerns, and Timo and others have shared with us today, really focus on the water cycle of the North. And we have several programs that are dedicated to hydrology around the world. Some of those focus on global river discharge. So one of the things Timo was sharing with us is about the freshening of the Arctic Ocean with these rivers discharging more and more water into the bays and the ocean. The other one that I've been really part of for several decades now is the Global Network for Isotopes and Precipitation. So many of us are interested in using isotopes to understand hydrologic processes. And then we've also recently, in the last few years, as part of that Action Program, we've established the Pan-Arctic Precipitation Isotope Network, which involves about 30 sites across the Arctic that every time it rains or snows, they collect that sample for us, and then we're analyzing those and beginning to look at how moisture moves into the Arctic, around the Arctic, and out of the Arctic using isotope geochemistry forensics. The Cryosphere. This is, again, a place where dramatic changes are taking place, and we're all quite grateful, actually, to the major network of sites that Denmark has been dedicated to, putting around the island of Greenland, for instance. They've been able to show us very clearly that the ice sheet is thinning, and that basically means that new land is being exposed almost every day. So the whole ice sheet is changing, and we saw an example, precipitation. It rained at the top of the Greenland ice sheet. That's 3,000 meters is the top of the ice sheet. So this network, supported by both GEHUS and Aarhus University and the funding agencies in Denmark, have really given us a great understanding of the rates of change that are happening there. The other issue that's exceedingly important that's taking great advantages of networks is permafrost. We've been able to monitor permafrost temperatures for decades using sites all across the north. There's even a network of sites that are monitoring temperatures all the time. And one of the things that they've shown us is that clearly there are places that the active layer or the permafrost is actually thawing. And there are a whole series of cascading consequences. One of those that we've been measuring using 14C analysis is we can actually see ancient carbon being discharged into the rivers up in northern Baffin Bay. We can also see that permafrost carbon is evolving from the soil surface into the atmosphere. So we are now in a state where this disconnected carbon cycle of 20, 30,000 years ago is beginning to interact with our modern carbon cycle. But we exist on a blue planet. And many of the networks that I've shown you are very focused on land-based processes. But the other place that we've been working as a global community with more and more emphasis is in the ocean. And putting vessels into the ocean so we can take measurements there on the spot. And Mosaic is a great example of that. We've been doing that in the U.S. quite a bit with the U.S. Coast Guard cutter Healy, for instance. It also was the lead ship on the Sheba project, which was about 15 years ago. But there is a global community dedicated to understanding the ocean, even using ocean vessels that go back and forth across the Pacific to take measurements. So this is, again, another important place for the monitoring community. The thing that we've recently added to this is the Arctic Water Isotope Network as part of Mosaic. So Mosaic gave us an opportunity to put water vapor isotope stations all around the Arctic and simultaneously measure those on the polar stern. And so this has been a real advancement for us and important data sets that we believe will help us reinterpret the ice core records in terms of the role of sea ice in climate and water vapor characteristics, which are recorded in the isotopes of ice cores. Most of the things that I've just talked about are very much kind of abiotic driven. But there are organisms out there in the Arctic, and one of the most important set of organisms in the Arctic that affect many of the processes we're concerned about are reindeer in places like Finland and caribou in places like Alaska. And so we have a network that is dedicated to this issue called the Herbivory Network, and I'm going to say a few words about UArctic here in a minute. This is one of the UArctic networks, and so there is a community out there taking measurements, collaring animals, asking questions about where do you go and what do you eat if you're a reindeer, if you're a caribou. How does that affect trace gas exchanges? One of the things that we're doing with CAVO, for instance, which goes back to IBP, is CAVO was a place where they asked this question: what happens if we remove reindeer from these Lapland ecosystems? And they did that 60 years ago. So now what we have is we have this long-term experiment where we can take trace gas flux measurements inside an exclosure, which hasn't had reindeer for 60 years, and compare that to areas outside the exclosure in which the reindeer have continued to use. So this is one of the tools, the legacy of IPY, is it's helping us understand the role of herbivores in trace gas fluxes, which again is part of this whole issue of carbon neutrality. The University of the Arctic is a program that really has taken on a tremendous role for the last 20 years, and it's been tremendously dedicated to these connections between people and between universities and enterprises. And they have a whole series of networks. There's too many to put on a slide here. But there can be categorized in about 4 or 5 different areas. For instance, culture and social issues, health and education, natural sciences. These are all programs where there must be 15 networks that are underneath each one of these major headings and really serving as a role to bring people together around thematic issues that we find all across the Arctic. One of the places that we again look and might ask ourselves is how valuable are these networks? And if you go, for instance, and take a look at some of the literature that's coming out, which we all struggle to keep up with, some of the things that you see here again have societal relevance. The first one here, climate-driven risk to the climate mitigation potential of forest. My goodness, if that doesn't ring true here. Again, these are places where people are writing about how scientific discoveries can be applied to social issues today. The last one, ecosystem scale flux measurement strategies to assess natural climate solutions. Natural climate solutions. Again, this is turning green, right? This is how do we make this green shift? So here's a nice example of that. And so you ask, where do we go from here? And one of the things that I see as being really necessary today, and I'm going to try and get on my bandwagon about this, is it goes back to Apollo 11, mission control. And one of the things that mission control had and has today is that it basically can monitor, measure a lot of things simultaneously, because you're talking about a rocket launch. And that's one of the things that I see that we need as networks. And the second part of this Mission Control Center of Excellence that I'm aspiring to is involving the images of Avatar. I don't know if many of you saw that movie, but one of the things that they had in Avatar was a hologram. And that hologram was used to move images inside and out and to layer that. And so I have an image of a mission control center that includes a hologram, so that people that are interested in looking at, for instance, where are the reindeer compared to where are the wolves? If people are interested in what are the CO2 flux characteristics compared to the amount of snow that's on the ground right now, that you can move those data sets in and out. It's not about collecting more data. It's about being able to use that data for discoveries and understanding. And there's a program out there today, actually, that you might be interested in. It's by NASA. It's called Science on a Sphere. You have to Google this. NASA has created an incredible program to allow us in real time to observe the way the Earth is behaving and layering information in a 3D sphere. The Earth is dropped down on a big cable. It's right out here in front of us. It's half the size of this room. 6 projectors are up simultaneously, and literally you can sit here and start changing the configuration of what's being shown. You can show sea ice at the same time that you show water vapor currents, at the same time that you show ocean temperatures. And so one of the things that I feel that we need, and really am going to continue along this vein, is this thing that I call mission control. And I'll take any questions.
Thank you very much, Jeff. I do want to remind our audiences who are online that you can write your questions in the chat so that we can pass this on to our speakers. We don't have any questions online yet, but I do have a very small question for you, Jeff. You've been talking about the value of networks, and with your experience with the UArctic that has thematic networks across business, law, art, engineering, and so on, when we're trying to deal with climate, biodiversity, and health, in your experience, how can we best diversify our networks so they really cover, so we come together and cover all these disciplines and not work separately?
I think the key there is not work separately. And so getting people from these different networks into the same room is really a critical part of that. So having a network of A, B, and C actually coming around, for instance, a common problem. So creating a question, for instance, fisheries in the north is an example. Fisheries in the north we know is changing. We know the food webs are moving. And so by bringing these groups that might be business, law, science around that common theme, so then you can kind of talk and discuss. So when you hold a workshop, you don't hold it just for the biodiversity people or just for the law people or just for the science people. You hold a workshop that is focused on an issue. Fisheries in the north is an example I like to give.
Thank you. That was a very practical answer.